go. All right, hello everyone. Welcome to our 11 o'clock presentation. This is Building Your First SIEM with the Elastic Stack. My name is Daniel Dayley, aka Chronoside. Just to make sure you're kind of in the right presentation here, this presentation I was kind of gearing towards kind of an entry-level dive into what a SIEM is, kind of an overview of the architecture. We will go ahead and do a setup demo where we'll get one running and do a quick detection and alert. If we get enough time, we'll take a look at some visualizations. But there's a lot of really cool technology in the SIEM space right now, and I'm not going to dive deep into a lot of it. I'll make references to some stuff for you to go look up later, but this is really more about getting you introduced to what a SIEM is and kind of get you going or introduced to the Elastic Stack and how to get it integrated into your SIEM and how to kind of use it to build a SIEM off of. Kind of an overview, we'll talk about what a SIEM is. We'll go over kind of some considerations when you're designing your SIEM. We'll do an overview of the software that we're going to use in this demo to design and build it. We'll get a dashboard going, kind of go through that process. We'll get some alerts generated through ElastAlert, and then I'll talk about some things that you can do to kind of expand your SIEM and improve the threat detection capabilities of it. So we'll start out. What is a SIEM? When people talk about SIEM, it's actually a Security Information and Event Manager. It's kind of a combination of two technologies that have kind of existed in some form or another in the past, an event manager and an information manager, both geared towards security events and threat analysis, incident response. Basically what it is it's going to be a place that you can go as a security engineer to get visibility into your environment, to be able to analyze threats, handle incidents, and just get a good view of what's going on in your network. There's, I think, a lot of misconceptions in the SIEM space as the market has kind of developed as to what a SIEM does not do. The first and number one thing is that a SIEM is not a replacement for good security controls, good firewall rules, ACLs, your traditional network security techniques. Your SIEM is not going to replace those. You still need those. A SIEM basically gives you visibility into those but doesn't do the work for you. And one thing that I hear a lot, a misconception, is that a SIEM is just central logging, just a place to collect all of your logs. Central logging is good, and for a lot of companies that use it for marketing or research purposes or for customer database research, it's great for that. But a SIEM takes the logging a step further to give you alerts and dashboards and things that are really tailored to you as a security professional to help you, keep the bad guys out. So if you have central logging, you can actually expand that into a SIEM by adding that functionality. So, and then the number one thing that I think a lot of people have misconceptions with is in a SIEM, especially with a lot of the vendor claims these days in the SIEM space, is that a SIEM does not just understand your threats and vulnerabilities for you out of the box. You still need to understand at some level as a security engineer the sort of threats and vulnerabilities that you are trying to defend against. Your SIEM can only help you as far as you know what you're looking for and you know what you're trying to stop. It's basically just that tool to give you the visibility that you need to be able to make those intelligent decisions. So there's a lot of terminology in the SIEM space, and a lot of it means sort of the same thing. From vendor to vendor, there's slight variations in sort of the definitions of what things are and what things do. But generally, you have forwarders, agents, sensors, basically endpoints that generate log events. And these can generate raw logs or pre-processed logs, things that are going to give you information into your environment. You have enrichment, normalization, and parsing, basically the process of taking a raw log event and making it usable to the SIEM and to you as a human user. And we'll talk a little bit more about that. Collectors, ingesters, aggregators are kind of used liberally across the SIEM space as to what they do and where they're placed. They're basically endpoints that can collect logs, either raw logs or enriched logs, and store them either for enrichment or for long-term storage and searching. So that's all kind of the same thing. And then your indexers or storage nodes and search nodes are basically the places where your long-term logs are going to be stored, your long-term events. And one that I didn't put on here is kind of the difference between a log and an event. An event generally refers to an enriched log that has the data that you need to make your SIEM work. A log generally refers to the unformatted, raw mineral sort of data that you get out of something like syslog or Windows Event Manager. So there are a ton of really great products in the SIEM space, each with their own excellent features and different topographies, great use cases. They all kind of flex a little bit on some of the things that they're good at and some of their pain points. Here's some of the examples here. We've got Logarithm, Alien Vault, SolarWinds SEM are some great ones. An interesting thing that I put up here, we've got Splunk and ElasticSearch up here, which I think are some of the more popular ones, but those services by themselves are not SIEM products. They're mass data products or structured data search products. And the way that you use them as a SIEM is really just the way that you implement your enrichment and your threat detection. And so that's what we'll be doing today with ElasticSearch is we'll set up the ElasticSearch cluster, or well, it's just a single instance, and then we'll go ahead and implement some threat detection examples here so that I can kind of explain how you would use an existing log infrastructure to build a SIEM, or even if you're starting from the ground up, how you could build that on the cheap. So what we're talking about when we talk about the Elastic Stack, it used to be called the ELK Stack, you might have heard it referred to as that, is the suite of software produced by Elastic for managing massive amounts of structured data. You've got beats, which are generally those agents. They'll go on your endpoints to forward logs from Windows or from Linux to tell you what's going on. And you can configure beats pretty extensively to get whatever sort of information you need off the host. You've got great options in Windows for event logging, and Linux has a great audit D tool that will give you a ton of great logs here. Logstash is an excellent, excellent tool that I recommend in almost any SIEM space for enrichment because it has very extensible capabilities. It has its own programming language, essentially, that lets you write your own detections for the events that are going through it, whether they come from a network sensor or from an agent. Wherever you're getting these logs from, Logstash can make them better. ElasticSearch is really kind of the core of it. That's your database or where all of the data is going to be stored, your storage node there. And then Kibana is really just your UI for that. It's your interface into ElasticSearch. And so there's also a lot of great tools that you can add to this stack to enrich your SIEM and give it more SIEM-specific capabilities. Two that I'm going to talk about today are Zeke, formerly Bro, the network security monitor, and ElastAlert, which is actually developed by Yelp as part of their security infrastructure to do automatic alerting out of ElasticSearch and give you any sort of alert you want, whether it's email, Jira tickets, or Slack messages. ElastAlert can do pretty much anything you need it to. With the architecture that I'm about to kind of demonstrate, there are some advantages and there are some disadvantages that I think you ought to be aware of when you're thinking about designing your SIEM. The obvious advantages with using something like Elasticsearch is that it's free and open source. It scales really well, whether you're containerizing it, whether you just want to stick it on a big host. It scales really well however you want to scale it. As I'll talk about here in a second, it actually is the backend for a lot of open source SIEM projects that you've probably heard of as well. So if you get familiar with this model of SIEM, you're probably going to be pretty conversant in some of these SIEM technologies that you may have already heard about. And a lot of these things, like I was talking about Logstash and Beats, they're actually compatible with most of the proprietary components. Things like ElasticSearch can receive logs from other proprietary forwarders. So if you have, for example, an antivirus that you've distributed across your environment and it's dumping, antivirus logs, you can still pick those up and put those into your Elasticsearch environment, even though those are proprietary logs. And it's easy to kind of build out and expand. One of the major disadvantages to Elasticsearch is the amount of legwork that's required to get everything running. It takes a little bit of time and understanding to really get what's going on. There's a lot of moving pieces, as I've kind of talked about already. It is very, in my opinion, it's difficult to update. Like, you can have a major issue if you do not update it correctly. And if enterprise support is going to be an issue in your environment, then open source software, you're always going to run into some trouble with that. And probably the biggest disadvantage to this is that your threat detection definitions are going to be all handmade. This is where a proprietary solution is really going to shine, because they'll give you threat definitions, and they'll sell you on those threat definitions, and there'll be great, threat detection ability there. But it's like I kind of said earlier, it's kind of our job as security engineers to know what kind of threats we're up against and to know what vulnerabilities we're up against, and to do our best to kind of identify those and to build that sort of detection into our environment, because what you're detecting at your organization is going to be different than what someone else is vulnerable to, or the type of threat that another organization may have. So you do still need to understand that. These are 3 great projects that I'd recommend that are all Elastic-based SIEMs. The first one, Malcolm, is actually started out at the Idaho National Lab, was just released this summer, and it is a great project that integrates basically most of the components that we've talked about here with some additional network security analysis tools that are really great. Security Onion in the middle is probably one you've heard about quite a bit. It's an all-in-one package with kind of its own interface to manage all these different components without needing to go to each one and configure them all manually. And then the third one is Apache Metron, which I actually haven't had a ton of experience with. It's a relatively new player in the game, but it's getting quite a name for itself. So kind of a general overview of how a SIEM is going to be implemented in your environment. You're going to have network loggers of some kind, whether they're network security monitors or taps that go to some sort of quality assurance analyzer or something, and those are all going to generate logs. You'll have workstations that will generate their endpoint logs, and along with workstations, you probably want to get your server logs as well with those, and those are all endpoint logs. They all go to some single place where they can be either enriched or stored, or both, depending on how many resources you want to throw at it. And then from there, you'll query it with your dashboards, searching and reporting and things like that. Basically, the way that we're going to implement it today, we've got Zeke, which is that network monitor. It's going to take traffic from anything it hears on the network and start generating events. Hey, I saw a DNS query, I saw a connection here, things like that. It's going to be collected by our Beats agent, which is also going to live on the host. And Beats is also going to pick up our syslog messages and going to start sending those over to Logstash, where we'll go ahead and do some basic enrichment on those logs. We'll put it into ElasticSearch and then visualize it in Kibana. So I do have, I have the demo here, which I don't know if we can see it very well. I've got the URL down at the bottom. But basically, we start out with a default just kind of Ubuntu box, an Ubuntu 18 instance. We'll install everything on this single box, and we'll go ahead and run it all. In a normal architecture, I wouldn't necessarily recommend doing that. Maybe it works for your organization, but you're probably going to have a more distributed architecture like what I was talking about earlier. So the first thing that we'll want to do is go ahead and get the sources added for the Elastic Stack. We'll just add it to our apt repo. That makes it real easy to do the rest of the installs. We just do a apt install ElasticSearch. We'll do an apt install Kibana, an apt install Logstash, and then we'll do an apt install FileBeat. And all of this goes relatively quickly. What we're doing here, we're probably going to get it going in about 10 or 15 minutes. It might take you a little bit longer depending on your environment. This happened to have a blazing fast internet connection, which was great. I'm going to have the instructions for this as well posted at the end, so if you want to follow along with the kind of what these commands are, what we're doing, I'll have all of those laid out in a walkthrough for you, as well as links to the recordings here and to the slides. So we'll go ahead and get those installed. We're getting Kibana installed here. And so this is those first 4 pieces of software we talked about, Beats, Elasticsearch, Kibana, and Logstash. And those all come from the same place, so it's relatively quick to get going. And then that's going to continue to download here. Let me see if we can just fast forward some of this. Yeah, let's install Logstash. All right, so then installing ElastAlert is a little bit more complicated. We actually have to kind of install it from source. And it's not the worst thing in the world. There's about 6 commands here that we run to install Python, install pip to install ElastAlert. Again, ElastAlert is going to be that service that's going to check ElasticSearch every minute or every 10 minutes or however often you want it to. And it's going to generate log alerts based on definitions that we provide. So if you want to detect certain things and alert when certain things happen, ElastAlert is going to provide that for us. So we'll go ahead and clone that down and start building it here. That will take just a second. One interesting thing about ElastAlert is it doesn't come with a service. I go ahead and give you the instructions here on how to make a service so that it starts up automatically for you. And so that'll be kind of nice here. Gonna just move forward to make sure we don't go over here. All right, so we get ElastAlert installed. Oh, let's see. So the first thing that we're going to do here with ElastAlert is create that service, like I said. That's pretty straightforward. You just kind of enter the service details, and we'll get it enabled here. One of the, I think probably the most difficult one to get installed here is Zeke, which we'll go ahead and get that installed. So we're going to clone down the apt repo, or I guess add the apt repo, and then we'll go ahead and pull it from there. In your environment, you may want to consider building it because you could potentially get performance benefits from it. It does take a little bit to compile, though. Just be warned on that. So that we'll go ahead and install. It may prompt you if you want to configure Zeek to send email. I just go ahead and hit the default prompts, and then it will not send email by default. So, all right, so we get that set up. Now we want to go ahead and get configure Zeek to be able to grab all of our packets off of this one host. So I just went ahead and enabled promiscuous mode here. And typically on your Zeek, you're going to have a separate interface that you want to have a tap off your network, getting a copy of all the traffic that's going to and from your core router or your main firewall into your environment, so you can kind of see everything that's coming in and out. This could generate a lot of data for you. And so that's why you should take into consideration basically how many resources you want to give your Zeek box or maybe even a Zeek cluster to handle all of this data, depending on how much you have. But for this one, we're just going to use the promiscuous mode on the adapter, and we'll go ahead and listen on that traffic. So we'll change the adapter interface here to the one that we have, and we'll move on to changing the output policy. This is actually a big one. The Zeek has two logging modes. One is JSON and one is plain text. Plain text logs or syslogs are just a pain in the butt to enrich and parse because they have weird delimiters. Some of them have tabs, some of them have commas. If you have a common parsable format, something like JSON or YAML, even XML like Windows event logs is really easy to parse because it's already structured somewhat. So Logstash can intuitively pull out fields, and you can enrich those fields without having to do your own extraction. You can do that in Logstash. You can do anything you want in Logstash with logs, but it just takes quite a bit more legwork. So after we do that, we're going to go ahead and start Zeek on the interface. And when we do that, it should start generating logs for us. What we're going to do here is I just did a ping of yahoo.com. Wait a second, and then we just take a look at the bottom of that DNS log that Zeek generated. Zeek detected that DNS query and put it in a log. And it said, this is the IP, this is the host name it looked up. This is great for now. We are moving into a DNS over HTTPS world where this will become less effective. So keep that in mind as you're considering some of your threat detections. But for now, it seems to work well enough, and it's a great way to catch low-hanging fruit. You sometimes have to use your imagination with your threat signatures on some of the things you want to catch. And there's a lot of low-hanging fruit that you can catch, like taking every DNS name that's queried and putting it against a known malware list. I mean, that's a real easy way. If you have some common malware that gets into your environment and it's querying out on the network, then you're going to catch it by just looking at your logs and seeing that it's querying a known malware list. So now, let's see, we're going to go ahead and set up FileBeat. FileBeat, again, is that agent that was going to live on the machine. You're going to put these on maybe your Linux servers or your Windows servers to grab event logs and send it into Elastic. I've got a config here that's already configured to send it into our local Elastic stack or ElasticSearch. And again, I'll have all these configs available here at the end for you to go ahead and read on your own time. And I'll be available if you guys have any questions about setting this up. We're kind of going through a lot of information really quick here. So we'll get that FileBeat configured here, and we'll get it restarted so that it's running. The last thing that we'll need to do is make a quick change to Zeke's path so that it knows where to look for these logs. Well, sorry, I misspoke. We'll change FileBeat's paths so that it knows how to pick up Zeke's logs off the host and put them into ElasticSearch. And then so we'll just add those paths here and get those done. Then the last thing we're going to do on the Elastic Stack is probably the most intensive. And if you are using an Elastic-based threat detection system, Logstash might be where you spend most of your time. It's the enrichment part of the pipeline where we're taking raw log events and doing things with them. What's really cool about this is that you can go as far as you want with Logstash enrichments. You can use lookup tables, you can use REST queries, you can do just about whatever you want to put additional data into your log. And so you can end up with these massive files that continue to do this great threat detection. So Logstash has a great way of helping you organize all of that with these ideas called pipelines. And a pipeline is basically a step-by-step process that Logstash takes to make your log better. It has an input, where do I get my logs from? A filter, what do I do with my logs? And an output, as in where do I put them? Something to consider that I didn't really have time to go over in this, and I mentioned it earlier, is to put a message queue somewhere in here. And all that the message queue does is it's a place for your logs to sit, either before they're being enriched or after they're being enriched, before they go into Elasticsearch. And it's just kind of a great way to buffer when your events throughput doesn't match. For example, if you have a normal logging rate and you're enriching just fine, but all of a sudden you have a major traffic spike, and all of a sudden you're getting 3 times as many network events as you were before coming into Logstash, Logstash is going to say, whoa, this is going to take me a little bit, and it's going to start to queue up. And the rule of thumb with your SIEM and with log enrichment is to always make sure that your enrichment events per second, the number of logs that you're going through and making better, is higher or faster than the number of events that you are ingesting or taking in from the rest of your environment. This takes some calculation as to the number of resources that you want to actually throw at it. Because if you get to a situation where you have more coming in, you may be able to buffer that for a period of time. Maybe you know that at 8 a.m. every morning, everyone's logging into their workstations. You're going to have a spike of logs, but that's going to go down. So you can buffer that for a little bit. You don't need to throw a ton of resources at it. But if you just are constantly having more events come in than you can handle, you need to consider potentially putting a message queue in, potentially giving more resources to your Logstash instance. So we've gone ahead and implemented our pipelines here, and I'm just checking to make sure that FileBeat is running. We're going to go ahead and modify Logstash. Logstash has a really cool feature here where when you make a change to any of your configuration or any of your enrichment pipelines, it will go ahead and reload that pipeline automatically. So you don't need to restart the service, you don't need to edit anything, and I'm just enabling that here in the default config file. So that will work for us. So then our main enrichment pipeline, we're going to go ahead and build this. And what we're going to do is this is a quick and simple enrichment pipeline that will go through and look for any source or destination IP address that we get from our Zeek logs and compare it with a table that I've prepared here of known Tor endpoints. Now I know our previous speaker, Robert, was just talking about the great uses of using the darknet and bringing it to the light. And I think that that's great. I think right now in some of my use cases, there's not a lot of real legitimate uses for users in my organization to be on Tor. I think that more often than not, that's going to be a good indicator that something's not right in the environment. So what this is going to do is this is going to tag any log file that comes in whose IP address has a destination or a source address that is Tor, and it's just going to let me know in the log. So then when I can go through the logs and start searching, I can say, hey, show me all of the connections to Tor. And it can go through and show me all the IP addresses, when it happened, any of the connections to Tor. And this is just an example kind of starter threat detection example. So we've gone ahead and implemented that config there. We're going ahead and starting the Logstash service here. And now we're going to be ready to move over to Kibana, which is our dashboard. It's kind of our visualization interface here. All right, I'm going to kind of skip this part because we're running short on time here. Make sure we still got it here. May have to reload it real quick. Oh, are we live? There we go. All right. So once we get Kibana running, you can pull up the web UI, and this is going to be kind of your dashboard. This is what you're going to see when you first get in. And right now we have been sending data to it through FileBeat, and ElasticSearch. Remember, Kibana is just a visualization for your ElasticSearch. ElasticSearch bundles your logs by type into bundles called indexes. And it usually bundles them on a daily basis. There's other ways that you can do it. But the first thing that we need to do to really use these are to make index patterns. So we'll go ahead and create 2 index patterns here that will help us distinguish our data and kind of keep our logs separate, because not every log has the same events. Our system logs certainly aren't going to have the same fields in them that our network logs are. So we'll go ahead and create those 2 indexes here, or those index patterns here. This will just basically help us see all of the indexes that ElasticSearch, or that Logstash is going to make when it puts them into ElasticSearch, and search all of that data all as one. So once we get those added, I got to make sure I remember to select the timestamp for these. We can go over to the Discover tab here, and we can start searching our data. So let's see if we've got any data that we can actually pull up here. We can see our events, and we can see some of the data from the events. So I'm going to switch over to Zeke because we want to look at our network monitor. These are all of our network log events that are coming from Zeke. So now we can check and see if any of our data that we were just setting up with Logstash is working. First of all, I've got this destination.tor filter applied so that we can only see events here that have a destination of Tor. So I'm going to go ahead and make a connection to a Tor example, just using netcat, just to kind of prove the point here. And this should generate a log that's detected by Zeke, and that has my IP address and the IP address of Tor in it, and then that will show up as a flagged log for us to review. So we'll go ahead and refresh that. All right, there we go. So you can see these 3 events that just showed up here. It says that these are indeed Tor destinations. So if we come down, we can see that it was what the IP address of the machine was, what its name was, when it was that it connected, and that it was indeed a Tor endpoint. So we're kind of out of time here, so I'm going to go ahead and give you some further reading or some things that you can do to continue to build this out, as well as links to our slides. Things that you can continue to do are just enable control in Elasticsearch. Elastic made that free as of May. You get free user accounts, free HTTPS, all included. They just bought a great company called Endgame, so they're building out their SIEM. And they do have a SIEM module in here. I've used it, and it's still in its infancy. It's still really finicky to get working, but I think that it shows some promise. I think in the future they're going to have some really cool stuff with it, so that's something to keep your eye on. Just understand what data that you have. Try to understand where you aren't seeing things, where you need to see things, and shave down your false positives so that you're only getting alerts on things that you want. I'll go ahead and give you the links to the slides here so you can go ahead and review that. The walkthrough is posted here if you want to go through and finish that up and watch the ElastAlert section here. And the slides are here as well so that you have all of that information. And of course, if you have any questions, feel free to hit me up here at the con or on Twitter. My handle is Chronoside. And thank you so much for coming.